Welcome back. Here we're going to start essentially the material in chapter 2 of the textbook. We just got done talking about the different types of variables. We have categorical and quantitative variables, and we talked about how important it was to determine the context of a particular problem or situation so that we know what to do with it. So, in this video, we're going to concentrate on categorical variables or categorical data and what we can do with those types of variables. So, specifically, what we've got here are a couple tables representing the passengers on the Titanic. On the leftmost table here, we've got what class each passenger was a part of. So you have first class, second class, third class, and the crew of the ship, versus how many people were in that class. So first class, 325 people, second class, 285, so on and so forth. I was struck by how many crew members there were compared to the number of passengers. I mean, geez, that's like, well, we'll get to what percent that is. That's actually right here. It was a staggeringly high number in my opinion. Anyway, if we have a categorical variable, it might be nice to organize the data in a table like this. And if we've got the values of the variable, the classes, versus how many are in each group, this is called a frequency table. Okay? It essentially tells you the frequency of the number of individuals in each group. So, that's really cool. It tells us right away how many people were in each class. You can compare the classes to each other and say, oh wow, if we look at each class individually, the crew is actually the biggest class. That's crazy, right? You might think first class was the most exclusive, and maybe they had the best dining options or whatever on the ship, but there were actually more people in first class than second class. Third class was the highest number for passengers, and obviously the crew higher than any other individual class. So these are all things we can tell from the frequency table. It has value for making comparisons such as those. But these numbers are kind of big. For some people, maybe not for you and me, but for some people, we don't really get a good sense of how different these values are. First of all, we don't know how many people were on the ship right away, looking at this table. I suppose we could have added a row for the total and put the total number of people here, but that's not in this table. We'd have to do that ourselves. So, what proportion of the ship's people were first class? Well, this table doesn't tell us that. It kind of gives us an incomplete picture. So, if we want to answer questions like that, we have to make a table more like this. This one still lists all the different values of the variable that we've got, but instead of giving the counts, it gives relative frequencies. And relative frequencies can take several forms. They're all equivalent. You can express a relative frequency as a fraction, or as a decimal, or as a percentage. Any one of the three is perfectly fine. It all depends on what you want to highlight. If you want to say how many people were on the ship, well, maybe the fraction's the best measure there because you see that it's out of 2,201 people, right? There's not a huge difference between decimals and percentages in terms of data clarity for reporting to the public, but people generally attach better to percentages than decimals. Decimals are easier to work with if you're going to manipulate these numbers somehow, but percentages are best for actually reporting data. That's what people understand best. So, from this table, we can see, first of all, there are 2,201 people on the ship. And second of all, we know exactly the proportion of each class. So the crew, I was struck by how many there were. We can also see it was over 40% of the people on the ship were in the crew. More than 2 out of every 5. Maybe that's normal. I don't know. It seems like a lot, though. Okay. Whereas first and second class were both under 15%. Unless you want to crunch some numbers on your own, you're not going to get that information from a frequency table. You're only going to get it from, no shock here, except for me not being able to spell. It's a relative frequency table. Okay. And it's not like these things are completely different. They are telling the exact same story. They're just highlighting different aspects of it. If what you want to show is how many people are in each group, go with the frequency table. Okay? It tells a good story. If you're more interested in proportions or fractions or whatever, how much of the whole is in each group, relative frequency table is the way to go. But if you've got either one of these, you can easily recreate the other one. It's not like this came from nowhere. Okay? So, which table you use depends on the type of story you want to tell. And it's good for us that we can go back and forth between these two because different analyses we might do might depend on the counts, or it might depend on the proportions or fractions in each group. So, the table is nice. Both of these tables are fine. They're great. But you know what people like even more than tables? Pictures. Oh my gosh. If I had a nickel for every time that I had to, at the Census Bureau, summarize what I had done in a picture, well, I'd have a lot of nickels. Did I say nickel? I don't remember. I have a decent amount of money, right? So pictures are better than tables because you can easily see without any brain power whatsoever, ooh, look, that bar is really tall, right? Something like that. So let's take the information in our tables here and create a graph that will please the people who aren't going to take a class like this, right? They'll be like, ooh, pretty picture. So, since this is categorical data, right? This is not quantitative. I understand there are numbers here. But remember, the variable in these tables, the actual variable is the class, right? A variable is something measured on each individual. Every person on the ship has a class designation. This is a categorical variable. That's what these tables are for. Imagine if you had a variable like height, where someone could be any number of inches tall. This table, if you listed all the different inches that you could be, that table would get a little unwieldy large, right? So we only really use these tables for categorical data, and that also goes for the graph we're about to make. Categorical data only. So let's see here. Every graph needs a title. Okay. Something like Titanic Passengers by Class, I think does a pretty good job. And I'm going to start by making a graph for the frequency table. And we'll see how that graph would look different if we based it on the relative frequency table, but we're starting here. I want to display this information in a graph. So I'll make a basic L shape here. And graphs like this do not have to be to scale. It doesn't have to be perfect. If you're gonna be the type of person who immediately wants a straight edge and makes these lines absolutely perfect and makes sure everything is equally spaced, I'm not going to prevent you from doing that. But I'll tell you, it's going to take a lot more time, and it's not necessary to make these graphs perfect. Okay, we're not writing this up for a report for your job where your job's on the line. Okay, this is just it's AP statistics. It's just school. We're going for the big ideas here. Okay, so it doesn't have to be perfect. We've got our classes and we've got frequencies or counts. So those two variables are going to go on the two axes, the x and y axes, and the frequency or count is usually reserved for the y-axis. And the reason for that is, let's say we want to have bars that represent how many people are in each class. It's much more natural as a human being to see bars going up and taller bars being better than having the bars go like sideways and having the longer bar be the higher frequency. We want to see bars go vertically. So the frequency is going to show us how many people are in each class. So on that vertical axis, if we're making this graph by hand, I'm looking at the highest frequency, it's 885. I want to make sure that the top of my axis scale goes higher than that, and I generally want that to be a nice round number. So if I'm making this graph, I'm making the top of that graph 1,000, or the top of this scale. Okay. And to flesh out the rest of this vertical axis scale, I might count by 200s. Okay. So again, it's not perfect. Are these perfectly evenly spaced? Probably not, but it's close. You get the idea. And we'll label these by 200. Do you have to label it by 200s? No, of course not. You could go by 100s. You could go by 250s. I wouldn't necessarily just put 500 in the middle and call it a day. You probably need a little more detail than that. But it's all about what's easiest to read. Okay, so it's really up to you. For this data set, I think going by 200s looks good. So that's our vertical axis. Along the horizontal axis, we're putting which class each individual was classified into. So we're putting class. Okay. The labels on these axes are not optional. They must be there. Okay, whenever you create a graph in this class, both of your axes need to have labels. Someone that's looking at your graph and doesn't have access to the data that it came from needs to know exactly what your graph is talking about. You need to tell them that this is class and this is frequency. Those of you who took the one semester prob stats class, you already know that, right? Axis labels and title are the first thing that you put on that graph. So, the classes here, we've got first, second, third, and crew. Now, is it really important that we put that in order? First, second, third, crew, or could I put them in any order? There's no really hard and fast rule in that sense. Not every categorical variable has some kind of order to it, right? If we were talking about like the color of shirt that people wore when they first got on the ship, it wouldn't matter what order the color of shirts was in. But the idea here is the first class people, you would think at least it's the most exclusive. Second class, they probably paid less for their ticket, not so nice accommodations. Third class, they probably had the worst conditions, well, maybe except for the crew, right? So in this particular example, I think preserving this order is important. And you would probably do that naturally if this table was what you were given. Okay? But I want you to think, does the order make a difference here? And here I think it does. So for each of these classes, we're going to represent the frequency, or count, by creating a bar that goes up as high as its frequency. So for first class, we had 325 people. So we'll go up to where about 325 would be. That's about here-ish. And there's your bar. Second class, 285. That's going to be a little shorter. Okay. I'll pause there. Shouldn't these bars be touching? Like, I put a decent amount of space between these bars. But when you make a graph like this, don't the bars touch? It depends. The bars touch if you've got quantitative variables. So, this graph might bring back memories for those that took the one semester prob stats class, and I apologize if you didn't take that class. You're not missing a whole lot, right? But when we drew graphs like this, we connected the bars. And that's because we had a quantitative variable. Remember figuring out like the class limits and class boundaries and all that stuff? Right? That's because that was a quantitative variable. We were dealing with numbers on this axis. For categorical variables, these are just groups, and we want those groups to be distinct. Okay? So for categorical data, like this, we keep the bars separate. For a quantitative variable, we would connect the bars, but that's because these would be numeric. Okay. So we're going to keep the bars separate. Third class, 706 people. So that's out here. My worst grades in elementary school were in art. I am not an artistic person. These lines are not going to be straight. Some of my bars are going to be fatter than others. It's okay. It's fine. Crew 885. That's going to be the tallest bar for sure. That's going to be up here. I got a C in art in 3rd grade. That's the only C I ever received on a report card ever. My parents were livid. So, that's neither here nor there. So here we have a nice display of our passengers here. We can tell absolutely right off the bat. I could ask a 1st grader which class had the most people in it. And they'd be like, Crew had the most because the bar is the tallest. Right? That's what we want. Ideally, when we're dealing with complex data analysis, we want to make it simple so that people can understand what we're trying to say. Look, tall bar is highest. That is the most. Easy. Easily interpreted. Okay, we don't want to make things overly complex for no reason. So, that's great. This is a bar graph. Bar graph. And I want you to remember, bar graphs are for categorical variables only. The similar graph that looks like this, but where the bars touch for quantitative variables, that's a histogram. That's for quantitative variables, though. We're only talking categorical right now, so the bars don't touch. Perfect. So, that's one way that we can make a graphical display from a frequency table. If we wanted it to reference the relative frequency table, we actually don't have to change this all that much. This actually stays almost exactly the same. We only have to change a small part of it, and the part we have to change is the vertical axis. Instead of being frequencies or counts, now along this vertical axis we can talk about the relative frequencies. And generally we're going to be dealing with the decimals on this vertical axis of a bar graph. Okay? So we obviously have to change the scale now as well. We're not going up to 1,000. We're only going up to the highest decimal, which is 0.4. 0.4021. So why don't we change this to 0.5? This can be 0.4, 0.3, 0.2, and 0.1. Now it's a bar graph for relative frequencies. We don't have to change anything down here. We've still got 1st, 2nd, 3rd, and crew for the classes. We don't have to change the height of the bars. You'll notice 1st class is between 0.1 and 0.2. 2nd class is a little lower. 3rd class goes up between 0.3 and 0.4. And the crew is between 0.4 and 0.5. Perfect. Okay. 0.1 isn't exactly 200 because there are actually 2,201 people. So if I were making the relative frequency without having made the frequency on the axis first, these bars might be slightly taller or shorter, but relative to each other, they would be very similar. Okay. So, there we go. That is one way to graphically display the data in a frequency table or relative frequency table. You can make a bar graph. Now, there are a couple other ways I want to describe that incorporate some additional information, but to do that, I want to incorporate the textbook. So give me a second, and I'll make sure that that shows up in the corner of your screen right about now. So this is page 22 of the textbook, and you'll see here we have what's called a side-by-side bar chart. And the whole side-by-side deal is if you want to display the values of two different categorical variables at the same time. Two categorical variables that have the same categories. So we have the same Titanic passenger data that we were dealing with earlier. But here, now, you can see that we are looking at how many people survived, how many people were alive at the end of the Titanic's journey, and how many people died from each class. So you can see from first class, we have over 60% of the people in first class lived. And if you have learned about the Titanic, you know they were the first people to get life jackets, lifeboats, all that stuff. And then as you go through the ticket classes, you see that the rate of survival plummets and the rate of dying, or the mortality rate, increases as you go further down. So a side-by-side bar chart is really awesome if you've got two categorical variables on the same individuals using the same categories, because you can make easy comparisons between the categories. So you could say something like the crew had the biggest disparity between the percentage who lived and the percentage who died. Okay, you could tell that from this graph. And there are many other statements you can make. This graph is terrible because it doesn't have a title. It does have axis labels, it does have good scales, and it has a key, but it lacks a title. I guess you could say it's in the margin here, where it says figure 2.7 on the left, but I'm not going to let him get away with that. So that's a side-by-side bar chart. Two variables, same categories. And this graph is a segmented bar chart. It uses the exact same data that the side-by-side bar chart used. It just presents it in a different way. So in this graph, you can see the difference in distributions between those who lived and those who died by class. So you can see in the segmented bar chart that the proportion, what stands out to me is, first, I start at the bottom usually, the crew, a lot higher percentage of the people who died were crew than the percentage of people who lived. So almost, well, somewhere between 40 and 50% of all the people who died were crew, right? Whereas crew only made up about 30% of the people who lived. First class, people who died made up less than 10% of all the people who died. Okay, there are lots of different statements you can make based on a segmented bar chart like this. It might be the easiest way to determine, was the mortality rate independent of class? Or was there a relationship? Did the class that someone was in affect how likely they were to live or die? And by looking at this graph, the only way that the mortality rate and class could be independent is if those two columns look the same. They obviously don't, right? The tan crew bar is much higher in the dead column than it is in the alive column. It's the reverse for first class. A lot more first class people are alive than dead. So you could, by looking at this graph, say there's a relationship between how likely you were to live, to survive from the Titanic, and what class of ticket that you had. And so that's one of the most important things about a segmented bar chart, but it uses the same exact data as the side-by-side. It's just a different way of looking at it. It tells its own story. It's important to note that you can have even more than 2 categorical variables. You could have 3 or 4 or even more and still make these types of displays. But for the side-by-side and segmented bar charts, if you start having more than 2 variables, it starts getting really hard to read. It gets very difficult. If there were many more than 4 classes of tickets, a graph like a segmented bar chart would be very difficult to read. It's kind of like a pie chart that has like 20 slices. It's difficult to read. It's hard to understand what slice is which. Oh, pie charts. Right, I almost completely skipped over them. Silly me. Pie charts are also used as displays for categorical variables. Certainly you've seen pie charts before. The thing about pie charts, they're really hard to make, especially by hand. Unless you can draw a perfect circle or you have a compass on you, can't really make a good pie chart. And that really bothers me, a terrible artist that can't draw a good circle. So it's important to be able to interpret a pie chart. You can do that in the textbook. They have a section on pie charts. You can read it if you want, but in my experience, the AP test doesn't really emphasize pie charts at all. So I can't imagine that you would have to deal with one. Bar charts, sure. Segmented or side-by-side bar charts, perhaps. Pie chart, probably not. So, suck at pie charts. Should I say that? That was probably bad. I didn't really say that. So, on that note, this video covers pretty much the entirety of Chapter 2 in the textbook. There are some things I glossed over. Those are things that are not really emphasized by the College Board. So I'm choosing, especially since this is e-learning, I'm glossing over some things. You can feel free, if you want a more complete picture of these ideas, to read through the textbook. I feel like this textbook is very well written. It's easy to read. They write it in a conversational tone. It's not dry. It's wet, I guess you could say. I don't really want to say that. Anyway, so you can read the textbook. It's a really good read. I've read it several times. I think it's really good compared to other AP Stats textbooks out there. They really try hard to be funny at times, and sometimes they fail at it, but it's funny that they're not funny. They're at least trying. So, that's the end of Chapter 2. You do have a homework assignment for this chapter as well. You will have a couple days from the date of this video being assigned to complete the homework assignment. Check Canvas for the details on when that homework is due. You'll just do the work on paper and upload a picture of your work into Canvas, just like every other assignment you're going to do. And heads up, in the next couple days, you will have a quiz over the things we've covered thus far. So be on the lookout for that quiz coming up. Hopefully you're taking good notes so that you can look back on those so you don't forget anything, because you're not allowed to forget anything. Ever. So, have a great day, and we'll see you in the next video.